Hey guys, welcome back. We're going to look at this free response question. The principal of Pleasantville Elementary wants to estimate the true difference in mean height. So this is not a matched pair like the question we saw a minute ago. This is actually 41 boys and 41 girls, okay? So if we think back in some of my videos, in 1 is 41 and in 2 is 41. All right. Now, what is in 1? Well, in 1 are the boys and in 2 are the girls, okay? So what are some of the conditions? We have a 10% condition. All right. We have a large sample, normal condition, right? And we have that, we have just a random condition. So the first question is just saying, which condition is under examination here? So when we look, since the number of group 1 is equal to 41, and that's greater than or equal to 30, the central limits theorem states you're good to go. Since the second group is also greater than 30, the central limit theorem states you're still good to go. What about the random? In the problem, it's stated that the samples were random. So what additional information would you need to confirm that the condition for the test has been met? We also talked about these needing to be independent. So if you mentioned that, you got a couple points. That was actually kind of a good catch. They didn't talk about these being independent, and that would be important. But what's the big thing missing here? Okay, I think that the big glaring problem was that, like in a previous question, you'd need population 1 to be greater than 10 times that, and you need the second population to be greater than, why did I change that number? Sorry about that. That. And we don't know that. So it says, what additional information would you need to confirm that the conditions for this test have been met? We'd need to confirm that the population of girls is at least as large as 410, and population of boys is also at least as large as 10 times the sample size, which is 410. So you could have said at least as large as 10 times the sample size, but it seems silly if you actually know the sample size, you should just say 410. Now, why would this be suspect? Well, we're interested in making an inference about Pleasantville Elementary School. We need to confirm that the population of girls is at least as large as 410, and the population of boys is also at least as large as 10 at Pleasantville Elementary School. I can tell you at my elementary school, there was only about 100 kids in total. So this condition would not have been met. Okay, so let's continue. This is just part A. So what's part B? In part B, I'm going to do the full state plan, do, and conclude. Now, since this is not a matched pair, this is essentially the same thing I did last time. This would be, let's open and get our test going here. This would be stats. Are we doing a confidence interval? Yeah, we're doing a confidence interval. And we definitely have 2 samples, and we're not asking yes or no, so this would be a 2-sample t-interval. And we don't have raw data. They actually have given us the summary statistics, so we're good there. So let's type that in. What am I doing? In my plan, I really broke it out to explain it to you, so I've already written it above. So if you did that as well on your test, that would be fine. I didn't need to do it though. I just needed this part, and then I could have stated that down below. So in my do, I've got, and the only thing I'm missing from my plan is this part where I say we will perform a 2-sample t-interval. And why are we doing a 2-sample interval? We're trying to find mu1 minus mu2. And I could list that as mu boys minus mu girls, either way. So I've got x bar 1, s sub x1 in 1, x bar 2, s sub x2 in 2. So let's type those in. 54.31, 1.62, 41, 53.63, 1.85, 41. Going to keep that at the 95% level, keep pooled saying no, and I get my stuff. So what did the fancy calculator do for me? It took these two and subtract them and then created the margin of error. So it's going to take the t star that it actually does for me, takes the first s sub x1, squares it, puts it over n, and the second x sub x2 squares it and puts it over n. And so what happens in my calculator is it actually says it comes up with this value. The x bar difference is those things subtracted. I get 0.68. And all this margin of error, I get 0.764. All right, so what are the numbers? I don't really have my t star value because when you're doing it, it's combining these two numbers. So you can kind of leave it there. But you have these numbers. You can plug those in. Okay. So I state, plan, do it, but you're like, wait, I didn't do my state. What is it we have to do? Well, if you really are performing a 2-sample t-interval, then you need to state what this is. So mu b minus mu g, and again, you could have stated it 1 minus 2, is the true mean difference of, now I maybe need to glance back at my facts. Construct and interpret a 95% confidence interval with the true difference in the mean height of 5th grade boys and 5th grade girls. So the true mean difference of height in 5th grade boys and girls, and I could be even more specific, at Pleasant Elementary School, PES, Pleasantville Elementary School. All right. So what is our h sub o and h sub a? We should assume that they're the same. So we could show that mu b is equal to mu g. All right. So do we have a sneaky suspicion? It's not saying anything. So we should assume that they're just not equal. This is called a two-sided test. So it's going to test whether girls are taller or boys are taller, or either one are taller. We know sometimes girls are taller in different growth spurts, especially in middle school, or right around fifth grade, sixth grade. So what confidence interval we get? So I see here, I'm pretty much done. I just got my conclude. We are 95% confident that the interval from so let's get this from this question. The calculator even took 0.68 and added it and also subtracted it. So I get negative 0.08 and positive 1.44. So we're 95% confident that the interval from negative 0.08 to 1.44 captures the, and then I'm going to restate this again, captures the true mean difference of height in fifth grade boys and girls at PES. All right. Now, should there be a follow-up? Yes. At this level, we are doing a follow-up because we understand what they're actually saying here. We can say since 0 is in the interval, we do not have sufficient evidence to support that H sub A. Well, what is H sub A? That the two are not different. So since 0 is in the interval, we do not have sufficient evidence to support that heights of boys and girls are different. Check out the next video for the last free response.